Hello, welcome student to our channel, The Physics Point. In the previous lectures, we have just started discussions of the new topic, that is electrostatic. I will be said this is a new, not a new topic, the familiar topic of our electrostatic physics concept. In the previous years, we are discussed this one of the topic in the same title, that is electrostatic. And in the previous lectures, we are just revise what we are discussed in the previous years and just start to discussions with one of the concept, that is applications of Gauss law. In the application of Gauss law, we are find the electric field intensity with the help of charge distributions, and these charge distributions in the different things. And whenever we are discussed in the previous lecture, that is electric field intensity in the closed spheres which have the uniformly distributions of charges. Whenever we find the electric field intensity in that, just we get one of the answer here, that is one of the equations, sigma into r square. Sigma, it is density or charge distribution density. It means epsilon 0 permittivity of this free space, and this is r square. And this is the, we are taking one of the spheres which have the charge uniformly charged distributions. This is the radius of that spheres, and another one is also radius, but we must be taken one of the another point, they are outside to that spheres. And if we drawn one of the spheres with the help of these points, and that sphere radius is smaller. This is the equation we are must be find in the previous lecture. And in this lectures, we are again start with the same heading, that is application of Gauss law. This application of Gauss law or Gauss theorem. Application of Gauss law. This is must be second applications. We first will be discussed in the previous lectures. In these lectures, we are find the electric field intensity due to the infinite long straight charged wire. We find the intensity, that is electric field, electric field intensity due to a long straight infinite wire or uniformly charged wire, due to infinitely long or infinite long straight charged wires or uniformly charged wires. It means uniformly charged distribution. It means the electric field intensity is will be same magnitude in the all possible places on that straight line wires. Okay, which must be considered. Okay, consider consider a uniform infinite wires, uniformly charged distribution. Consider uniformly charged distributed, uniformly charge distributed in infinite infinite long straight wire, which is infinite long straight wire. Consider what we are considering here, the charge will be uniformly distributed. जे काही चार्ज आहे, जे काही आपण या ठिकाणी घेतलेला इलेक्ट्रिक फील्ड इंटेन्सिटी आपल्याला फाइंड आउट करायचं आहे कशामध्ये, एक इनफायनाइट लॉंग स्ट्रेट लाइन चार्जड वायर मध्ये जे काही चार्ज आहे ते चार्ज कसा आहे, युनिफॉर्मली डिस्ट्रीब्युटेड झालेला आहे असं आपल्याला कन्सिडर करायचं आहे. And if they are uniformly distributed, then the density, linear charge density, it means they have the linear charge density is constant. Linear charge density which are constant, linear charge density which are constant is denoted as lambda. Lambda, it means charge density, it means that is distributed by charge is the along the length. Linear charge distributed, it means the charge upon length. This is the density, linear charge density. These all straight line wire, infinite straight line wire, which are kept in one of the medium, which have the permittivity of that medium is denoted like this. Then the K is the constant of permittivity. K is the constant of permittivity. This K will be 1, or the value of K is unity when we are taken the medium is air medium or vacuum mediums. When we are taken the air medium or vacuum medium, then the constant of permittivity must be unity, or it must be 1. Then according to the Gauss theorem, according to the Gauss by Gauss law, the electric flux through a closed Gaussian surface, the electric flux through a closed Gaussian surface is equal to net charges divided by permittivity of free space. This is the equation we are must be solved, we are must be proved in the previous year in this under the same title of the topic, that is electrostatic. Let us draw one of the diagram. Consider this is my wire, uniformly charged wire, which have the infinite length, and this is the center. This is the center of one of will be line passing through the center of that wires, and the capital R. I will be used. The capital R is the radius of that wire, and I will be used another one is radius here. Another one is smallest, or which have the more area from the wires, and this is another one surfaces, or another one is uniformly charged infinite, not infinite, but it is smallest area, and this is the point is the P, and the distance from the point P to the center of that wire, uniformly charged wire, is a small r, denoted as small r. We want to find the electric field intensity at the point P. We want to find the electric field intensity at a point P, which have the radius is small r, and the coaxial length, that is L with the coaxial length. L with the coaxial length of that wires, and we want to find the electric field intensity of that wires at the point P. Now I will be drawing one of the smallest area here. Consider this is very small area, very small area, that is I will call this ds. The very small area is ds, that is, or very small Gaussian surface, very small Gaussian surface. This is the very small Gaussian surface. Then at the point very small Gaussian surface ds at point P. This is at point P. Now I will be said the charge will be uniformly distributed. If the charge is uniformly distributed over this area or over this diagram, then the electric field intensity or the intensity of that charge will be similar at all possible places. Similar at all possible places, and the intensity of the charge will be directed outward along that radius. Then this is the electric field intensity, direction of electric field intensity, and when I will be drawn the normal of this surface, smallest surface is also in the directions. This is the normal direction, and the angle of direction. Whenever we want to discuss the angle of directions, is must be zero. Angle of direction, it means the line or the directions of electric field intensity is said, that is radially outward, and also in between the normal of the surface and directions of electric field intensity. या दोन मधला अँगल काढायचं म्हणजे angle of direction it must be 0. Then the angle of direction angle of direction is 0. Angle of direction is 0. It means theta is equal to 0. Then if theta is equal to 0, cos of theta, cosine of theta, theta is 0, then cosine of theta is must be unity or 1. We know that electric field intensity, that is E dot ds, E bar dot ds bar is equal to E dot ds into cos theta. Cos theta is must be 1. Then E bar dot ds that is equal to E dot ds. It only have the magnitude, and this is have the magnitude as well as direction. This is vector. We show the arrow on the head of the any letters. Now we know that electric flux, the smallest electric flux at the smallest area, the smallest electric flux at the smallest area at the point P will be find d phi. D phi d phi is the smallest electric flux at the smallest area. This is the smallest area ds. Then E dot ds. Okay, E dot ds. Whenever I want to find the total electric flux overall the charged surface, then we take the integrations of this. The integration of d phi is equal to integrations over closed surface E dot ds. Integration of smallest electric flux is get larger electric flux, that is d phi is equal to E into integration of ds. ds it is the linear distribution. एक सरळ रेषेतला आपल्याला इंटिग्रेशन काढायचं आहे, and the area of that linear, this is 2 pi r. Phi is equal to E into 2 pi r into the having length. This is हा l आहे, त्याचबरोबर हा r आहे, आणि आपल्याला काय पण करायचं, फाइंड आउट करायचा हा जो सरफेस आहे, सरफेस एरिया ह्याच्यावर आणि ह्याच्यावरचा जो सरफेस एरिया आहे तो फाइंड आउट करणं म्हणजे 2 pi r into l. Then we know that it is electric field, electric flux is equal to E q upon epsilon 0, that is equal to E into 2 pi r into l. The linear charge distribution या ठिकाणी लिहिलं होतं, that is q divided by l. The linear charge density of that particular Gaussian surface or infinite distribution wire, then the q is equal to lambda into l. हा काढण्याचं तात्पर्य म्हणजे काय की this wave will be substitute at the point of q, that is lambda into l divided by epsilon 0 is equal to E into 2 pi r into l. The l will be same on the both sides, and also in the numerator they will be cancelled. Then lambda upon epsilon 0 is equal to E into 2 pi r. This 2 pi r will be multiplied with the electric field intensity. We know that we want to find the electric field intensity. This is the electric field intensity. Then this multiplication factor will be goes opposite directions of electric equal sign. Then they get divided with another side. That is lambda divided by epsilon 0 into 2 pi r. This is the value of electric field intensity over any point, because the charge will be distributed uniformly in the overall the length of that wire, infinite long straight wire. Then what we are do, or what we are done in these lectures, whenever we find the electric field intensity, we consider one of the infinitely long straight long wire which have the uniform distribution of charge. Then we know that if the uniformly distributed, then lambda is equal to lambda, it is lambda is the linear charge density of that wire. Lambda is the linear charge density. Then this all system will be kept in the one of the medium, and the permittivity of that medium is epsilon. Epsilon is equal to epsilon 0 into K, and this K will be constant of permittivity. And by using the Gauss laws, we are must be deals about the application of Gauss laws. By using the Gauss laws, we know that the electric flux through the closed Gaussian surface is must be equal to the total charge or net charge which are distributed in that Gaussian surface divided by epsilon 0. By using this, we want to find the electric field intensity at the point P. P is the some outer sides of that wires, and the radius of the wire and P will be changes. P, which are makes one of the another sphere or another circular hollow cylinder. Then consider a very small area or very small Gaussian surface at a point P is a ds. Then angle of direction is must be 0. Angle of direction is must be 0. Angle of direction, it means the intensity, direction of electric field intensity which are directed outward along the radius. Along the radius is capital R, which are directed outward. And again the normal of the Gaussian surface. या दोन्ही मधला angle it must be 0 because they are directed or coincident on each other and directed in the same direction. Then the theta is equal to 0. It means cos theta is equal to 1. We know that electric field intensity, that is E dot ds, is equal to E dot ds into cos theta. Cos theta is 1. Simply get these equations. We know that phi is equal to E dot ds. त्याचं यूज करून आपण या ठिकाणी काय केलं, and we must want to find the electric flux at a small area ds is equal to d phi is equal to E bar into ds. Then d phi, integration of d phi, when we want to find the total electric flux, that is d phi is equal to integrations into E dot ds is the constant because they are uniformly distributed all places. We're taking outside, and ds is the area, that is linear area, that is 2 pi r into L. L is the length, L is the coaxial length. Then we know that using by the Gaussian theorem, that is Q upon epsilon 0 into 2 pi r into L. Then we know that that is the linear charge density is equal to charge upon length, that is linear length. Then Q is equal to linear charge density into the coaxial length. We will be substitute the value of K and these equations, and we get another equations and find the electric field intensity. This is most important to find the electric field intensity of that material, or sorry, not a material, of that type of the diagram or infinite long straight line charged wire. Okay, let's stop here.